Hello, we're going to look at 5.2, properties of exponents and logarithms. And most of this should be something you've seen in your other classes before, so we'll go through it kind of quickly. So the first property we have, if you have two exponents and you multiply them, all you have to do is you keep, well, the a is called the base, and when you multiply them and the bases are the same, you could take the exponents and you can add them. That's the first property. Now, if you divide them, then when the base is the same, you can subtract the exponents. If you have an expression like this, an exponent to some power, well, that's the same. You can multiply those two powers. And another property, we should know that any number, no matter what, to the 0 power is equal to 1. If we have a negative exponent, that's the same as writing it as a fraction. So I can change, this is over 1, and I can bring the power down and make it positive here. But a has to be not equal to 0, obviously, otherwise we'd be dividing by 0. And then the next property that we have is number 6, and if we have something to a fraction exponent, then we can write this as the root of that power. But a, once again, has to be greater than 0 for this to work, right? So first thing we're going to do then is we're going to look at example 3, and it's going to have us come up with another property. So, and I'm going to use the other properties to help me with that. So if we look at example 3, and it says, I'm going to kind of zoom up here a little bit. So I have all my properties right over here to the left. And it says show that a to the m over n power is equal to the root of n to a to the m. And so the way that I'm going to show that is that a to the m over n, well, that's the same as a to the m over 1 over n, right? And then I can use my fraction exponent property here that I have right here, and I know I can write that as a root. So I can say this is equal to the nth root of a to the n, right? And that shows the first one. And then B asks us to, the other way around, show that the root of a to the m over n power is equal to the root of n of a to the m power. So it's pretty much the same thing, but I can just write this as a to the 1 over n to the m power, and then inside of it I have the root of the nth power of a to the m power. And there you go. And then that brings us our next property. We can write a fraction exponent like this in two different ways. We can bring, this could be to the a to the m power to the nth root, or it could be a to the nth root to the m power, a greater than 0. So there you go. So that's our property. Let's solve some problems using this. We're going to look at example 4 first. So example 4 says we want to evaluate the 27 over 8 to the 2/3 power. Now I'm going to use the property that we just showed right up here, and I can use either one, but I will tell you with these type of problems, the second one right here is usually the easiest. You could write it like this, but we're going to end up, if we did this way, we'd end up making the problem bigger. It could still get done, but it just makes the problem a little bit harder. So I'm going to write this guy right here, 27 to the 8th. That's going to be a 3rd root, so I could take that to the 3rd root and also that to the 3rd root, but I still have to square it. And then I know the cube root of 27 is 3, and the cube root of 8 is 2, and then I can square it and I get 9/4. Good. Here, the next one, I have a negative exponent, right? So that makes that 1 over the, and since it's a 2, it's going to be a 2nd root of 144, right? And the 2nd root of 144 comes out to that's 12 squared is 144, so this is equal to 112. And then this one here, there's a negative outside of it, and this is so the negative is going to stay there. This is going to be 1. I'll write it like this. The cube root of 125. And what is the cube root of 125? That is going to be 5. So this is just going to be a negative 1/5. Right? The negative was outside of it, wasn't being taken to the root, and there you go. Let's look at example 5. So if I look at example 5, it says simplify the expression, so on. So it says I have parentheses to 20 to the 9 to the 2n plus 1 divided by 5 times 3 to the 4n plus 1. Well, the numbers I can just divide. 20 divided by 5 is just 4. But then I'm going to end up with 9 2n plus 1 divided by, and I should write parentheses so I see what's going on, 4n plus 1. Now, I cannot divide that yet. I can't use the properties unless the bases are the same. But I can change 9. 9 is the same as 3 squared. So 3 squared means I'm going to multiply. If I change this to 3 squared, 2 needs to distribute out here. So I got 4 times 3 to the 4n plus 2 divided by 3 to the 4n plus 1. And now I have the bases are the same, and now I can subtract. Since it's dividing, I subtract the power. 4n minus 4n is 0, 2 minus 1 is 1, so I got 4 times 3, which is equal to 12. And I came out to something exact. All right, and then the last problem we're going to look at is example 6. And example 6 is this guy right here. So it says I have 3x plus, let's get a little closer so you can see it better. I got 3x plus 1 minus x equals 4. Well, I can rewrite this as 3 times 3 to the negative x equals 4. Now, I don't like that exponent, negative exponent, and I can get rid of it by multiplying both sides by 3 to the x. But I make sure I do it this side too. Now, this becomes base is the same when I do my multiplication. It's going to be 3 to the 2x. When I multiply that times that makes x minus x is 0. 3 to the 0 is 1, but I still have that guy left, so it's plus 3. And then I have 4 times 3 to the x in simplest form. Now, what I notice that I have here is I can go ahead and subtract this to the other side. So I have 3 2x minus 4 times 3 to the x plus 3 is equal to 0. And what I have here is in a quadratic equation. I have 3 to the x squared minus 4 to the 3x plus 3 equals 0. And this is a quadratic. Squared, one term, and then a constant term, right? So I can factor this, find out when this equals 0. So I got 3x and 3x. This times this is 3x squared. And then this is positive, this is negative, so they're both negative. And then it's just going to be 3 and 1, right? And we can check that this this term is a negative 3 times 3x, and this is a negative 3 to the x power, and that's a negative 4 3 to the x power. So this is the proper factorization. So what does this mean? This guy equals 0, so that means 3x equals 3 as one possible solution, right? Well, this means that x has to be, so x has to equal 1, right? And this here means that 3x has to equal 1. Well, for that to equal 1, then x has to equal 0, so x equals 0. So I have my two solutions. So once again, these type of problems, kind of one that students miss is recognizing the quadratic form, and this can happen not just with the exponents. Something can look a little bit different, but you know the quadratic property holds no matter what kind of functions you're using. And there you go. Thanks.